So exceptions. They are for when exceptional things happen in your program. All right, so let's get started. I have a few things to talk to you about. If nothing else, you'll be able to laugh at this meme, this old meme, by the time we're done today. All right, so here's an example. I'm going to try to motivate the power of this concept called exceptions to you. Okay, so let's pretend that we are writing like a division function, something simple, something that eventually does division, let's say, and we want to get it right. So you could run into some problems with division, can't you? You don't want to like crash the program when the user gives you something bad. So like here's your divide function. Integer division. Int divide some dividend. That's the thing on the top, right? Dividend by some int divisor, the thing that's doing the dividing. So you really don't want that divisor to be 0, right? And so like you're going to do something like this. Return in the body. Return dividend over divisor, something like that. Boop. And of course, something could go wrong. So let's get here. Do you see where something could go wrong? Let's make this happen. So let's say we have a divide function. Int dividend, int divisor, very Latin kinds of words. And then we, return dividend over divisor. Something like that, and let's call it. So let's say that our n1 is always 42, and then n2 is whatever we get from the user. So let's ask the user to enter a divisor. And then I think you see where I'm going with this, right? The program could either blow up or not blow up, depending on what the user gives us. Divide n1 by n2. So this is a very simple program. Let's compile it and run it. There. Boop. So if I enter a divisor of like 2 or something normal, it will just divide 42 by 2. It's like, yeah, sure, your answer is 21. But if I enter a divisor of 0, I'm going to get a runtime error, and we don't like that. Okay. So wouldn't it be nice, right, to not have that ever happen? Yeah. So wouldn't it be nice to like alert the user, like you ran this program the wrong way, or you ran this function the wrong way? We have to deal with the error, and all that we know how to do right now, all the syntax that we know how to fix this would be just like handling the error, that's the technical term, with some if statements, which can get quite tedious. Okay? So that's going to be the problem. We would have to use, right now, with our current knowledge of C++, we would have to use a bunch of if statements to prevent this error from happening. Use a bunch of if statements. And that's so sad. We don't like that. It's my best sad face. There. So what would you do? You'd be like, if the divisor is equal to 0 or something, do something. And the goal is to not stop the program, right? So you have to pick an int to return still, even after you complain. So there's a problem, and it's kind of dumb, right? So it's not really helpful, no matter what you could do right here. Like, you could do this. You could be like, if the divisor is equal to 0, then you can, like, see out something, complain to the user, bad divisor. But your job for this function, if you don't want the program to end right now, if you don't want to call exit or something, you have to give back an int, because that's the return type of divide. You have to say, like, return -1 or some special value. Now when you receive -1 from this function call, you're not sure, like, did I just divide 2 by -1 and this is the answer? Or like 2 by -2 and this is the answer? Or did I do a bad division? You have to like check the output. So it's not very nice what's going on here. This is not a great setup. I hope you will agree. So again, we can skip that if statement, or we can hit it. At least we're not getting a runtime error now. We're returning some secret value that we've kind of chosen. Check for it now, maybe. So that's kind of disgusting. And so there's a better way. It's called exceptions. All right. An exception is a new kind of thing that you can have. It's a piece of syntax. It's a bunch of pieces of syntax, in fact. And it allows you to signal that an issue happened, like something exceptional occurred. That's why it's called an exception. And you're not required to give back an int. You can give this exception thing. And the metaphor is like an exception is like a ball and you throw it. An exception gets thrown when it happens. And to handle that exception, to deal with it without causing a runtime error, you catch it. So that's the cute little metaphor. So like, somebody notices the problem and they're throwing this exception. And then somebody with a glove somewhere in your program, so it's getting thrown, and then somebody with a glove somewhere in your program knows how to catch it. Okay, that's the idea. That's the metaphor. That's also the syntax, honestly. So let me show you a better way, or let me show you how to use exceptions, because they already exist in the standard library. You've been seeing exceptions be thrown to your programs, but you haven't been handling them, so they've turned into runtime errors. You've seen these already. So let's use existing exceptions. Let me show you how to do this. So vectors, for example. A vector can throw a type of exception in the standard library called out of range if you try to go somewhere in the vector that doesn't exist. And you've seen this. So let's go there. So vector, containers, vector. If you try to, in the vector class, if you try to do like a .at, and you go to a weird place, it's like, if it is not within the size, an exception of type out of range is thrown. There you go. So there's an exception. It's just an object. It's going to get thrown to you. It's just a value. And you can catch it and handle it. All right. So let me show you that. We'll use this as an example. So this is going to be a good learning experience. So the syntax to handle exceptions is called a try-catch block. Well, that's try-catch.cpp. So we want to do vector stuff. And then let's make a vector. Something like that. And let's see here. Let's try to access the end of it. Because like if I make this vector, what does it look like? It's this. It's got 4, then 5, then 6 indices, valid indices 0, 1, and 2. If you try to access index 3, it will throw an out of range exception. All right, we don't like that. But that's nice. It'll tell us about it. And so let's watch that happen. Let me try to do this. Cout v at index 3, which does not exist, right? And so this is going to throw an out of range exception. And you've seen this before. I'm sure you've made this mistake already. Oh, sorry, wrong program. Boop. You've seen this, right? This is the exception turning into a runtime error. It's like throwing an instance of out of range. You got that value, and it tells you some information baked into that exception value. And because you did not catch it, it stops the program, because it's like, well, if you didn't know how to handle it, you must have expected this to be the end of the world, and I'm going to stop the program for you. That's what C++ thinks. But we could handle this, right? We could handle this error with a try-catch block and do something, right? So here's the syntax. Let's catch it and recover without having the program end itself. So you use a try-catch block, and it looks like this. You say try, and then you put some braces. And then in the body of the try block, you put any code that may throw an exception. All right? May not throw an exception. It's going to attempt to run those pieces of code, and then it'll also, in the corresponding catch blocks that are attached, it will handle any exception that you say you know how to handle. So you say try, and then you put in here any code that might throw an exception. Code that you want to run that might throw an exception if something exceptional occurs. It might not. So C++ will try to run all of this code, if it can. But if an exception happens, you're going to attach some catch blocks, kind of like your else ifs or else statements. You say catch, and then you give like a function call, or like a function declaration, you give a variable name for the kinds of things and the type of what you want to be able to catch. You're claiming now, I know how to catch an out of range exception. And then you can give it like a name. You catch exceptions by reference, by the way. That is the standard way to do it. The reason has to do with a concept called inheritance that we do not get into in this class. But always catch exceptions by reference. Exception values by reference. Out of range E, and then I can give braces and be like, all right, here's what I want to have happen if the out of range exception occurs. If somewhere in the code an out of range happens, it will jump to this code block. It will stop running everything else in the try, and it will jump here, and here's where you can handle that out of range exception. Handle out of range exception. Give as many lines as you need, and you have access to the exception value as well. You're catching it, and you've given it a name. You can inspect the E variable if you would like. So that's what exceptions are all about. So somebody's throwing, the vector class is throwing this exception inside of here, but we could catch it if we put it in a try block. So if we say try to do this, but if something exceptional happens, let's catch any exception that we know how to do. And you can have multiple catch blocks, by the way. So maybe this throws an int, maybe it throws also an out of range. You can have multiple kinds of exceptions that you can catch. It'll just jump to the one that happened. So I want to catch an out of range exception as a reference. All right. So what's going to happen in this body here is C++ will jump here if an out of range exception occurs in the try block. All right. And so it's your job here to handle the exception. Do something like restart your ideas, ask the user for another index, whatever you needed to do to solve the problem without a runtime error. So like, just for fun here, we'll just output uh-oh or something. That'll be how we handle it, and we'll go from there. Yeah.
In the try block, can you put, so if you put multiple things in the try block, then and you catch like the first thing, will it go through those other few things?
It will never come back. So the first exception, it jumps to the catch block, and then it's done with the whole thing. Yeah, so you'd have to come back around on it if you needed to go to the rest of those lines. Good question. So I'm going to get there, I promise. I have an explanation of that in just a second. But the idea is that if you have multiple lines in your try block, it's going to break out of this. It's going to jump out the second the first exception occurs. So we will never get to this line of code. It will never come back to it. Does that make sense? Because when something exceptional happens, it's like nothing makes sense at this point. You better go fix the problem. I'm never coming back here until you fix the problem. That's the idea. So the second this happens, by the way, when an exception gets thrown, v.at doesn't have to give anything back. Like, we're not going to see out anything. We're going to jump straight once the problem happens to this handler, print out uh-oh, and that's the whole thing. So we see uh-oh, that's our output. That's the idea, all right? An out-of-range exception, by the way, it's just a value. It's a value that exists. It has a class. It has a name. This. It has some member variables. It has some methods that you could call on it. It has a cute method called what. It's like the standard library exception classes all have the what method defined on them, which is a cute name. And all that does is it returns a C string that is supposed to hold a description of what went wrong. So that's kind of funny. So you can see out the results of calling e.what as well. And that is by default getting printed out to you when an exception occurs and you didn't handle it. You see that in the output there. Whee. It's calling it for you, trying to be nice. And so here is me handling the exception and also inspecting the what methods thing. It's like, that's your problem. Go deal with that. And so maybe you wanted to log that in your program somewhere. But yeah, that's how you can catch an exception. Right? You have your try block. I brought this femur for pointing purposes, so I'm going to use it at least once. So you got your try block where something bad might happen, and then you can catch multiple kinds of exceptions with your catch block. It's going to jump straight here. When the at throws the exception, it yells like, I don't know how to do this. So it jumps to this code, and you're done with the whole try catch block. Okay? Thank you, femur. All right. So, what else do I want to say? Yeah, every exception, like, you could throw an int can be thrown, a double can be thrown, and out of range is just a value, it's just some class that somebody made somewhere in the standard library. You can throw any kind of value as an exception. It's called an exception when it gets thrown, that's all. You can throw any kind of value, you can throw 42, throw 3.14. Yeah, so let me show you how to throw your own exceptions. There are some standard kinds of exceptions defined for you in the standard library. There's a standard except header where those exist. There's like a nice default one called runtime error that you can build up with like a string description inside of, so that's kind of nice. Let's go to standard except. There's a few of them. Out of range is where that lives as well, if you want to make your own. But runtime error is a standard kind of exception that you might want to use one day. It inherits from the exception class, if you remember me saying that before, so that's where it gets its what method. But to make a runtime error object, its constructor takes a string description of like what went wrong, and that's what it's going to give back when you call the dot what method. So you can use these kinds of exception objects, or you could make your own class, throw an object of that type, or you can just like throw 42, whatever you want. But runtime error lives there. Its constructor takes that string, and that's what you get back when you call what. What else? But you can throw any type, all right? Not just stuff from standard except. And the syntax is legitimately you just say throw, and then you give the value that you'd like to throw as an exception. So you can just say throw 42. Is that legible enough? Let me rewrite that. You just say throw 42. That's it. You can throw 3.14. That's all. Something like that. But you can throw any type. You can throw a runtime error object. So let's make some functions that throw different kinds of things. Let's make a function that throws a string, a function that throws an int, and a function that throws a runtime error. And then we're going to try them out. All right? So let's see here. Why did I include that? That'll be fun. Okay. Throw.cpp. So here's the flip side. When you, as a programmer, notice something has gone wrong, you can throw an exception. It's somebody's job to set up a try-catch somewhere. So I want, standard except, because we're going to use runtime error. I would like to use strings, and for a fun reason, I would like to use randomness as well. We're going to throw random exceptions so that we can catch different kinds of things. So let's make just some simple functions that throw stuff. So void throw string. Here's a function that, I don't know, apparently something went bad. String s equals blah, and let's throw s. You can do that. So that's throwing it as an exception, right? Same for throw, let's do throw int. So that's legitimately all the syntax. You just say throw and then a value of that type, whatever type you want to throw. And then we'll do throw runtime error. And then you could say like, I don't know, let's make a runtime error object. We'll call it RE, I don't know. And its constructor takes a string, so like put whatever you want inside of it. I'll just say the string uh-oh, and you can throw it. So that's legitimately it. Usually you'd be in an if statement somewhere, and like if something really went wrong, you'd use a throw. But these are just functions that immediately throw things. By the way, their return types could be anything, because the second you throw something, it's never going to return. It's just going to go straight to a handler somewhere. That's kind of interesting. So let's make a, let's do this in a very roundabout way. All right, let's make a function called, I don't know, I'll call it do stuff. And the idea is this will randomly throw one of these three exceptions. All right, that's my setup. That's where I'm going with this. So void do stuff. And so let's make a random variable. Let's call it choice equals rand mod 3. And I want to seed the random number generator, so this is different every time. So srand times 0. So rand mod 3, and so the result could be either 0, 1, or 2. So if choice is 0, let's throw an int. So I'll run that throw int function that throws 42. And then else if choice is 1, I'll have it throw a string, and then else I'll have it throw that runtime error. All right, so that's the setup so far. Does that make enough sense? So I'm calling do stuff in main, and it's going to throw randomly one of these exceptions because that's what we programmed it to do. We got all these throwing functions. Gotta save that first, I guess. So just randomly, it's going to start throwing stuff. It's throwing an int. It threw an int again. It threw a runtime error this time, and then it's calling what for us? Nice. And because we're not catching any of these errors, it threw a string this time. Because we're not catching any of these errors, they turn into runtime errors. But we could catch them. So one place to catch them is in main. So we might get an int thrown, a runtime error thrown, or a string thrown to us. So let's wrap around this function call, because that's the one that might throw an exception, right? In a try block. Put it in here. And then you write catch blocks for all the different things that might happen, right? This will always throw an exception, right? So we're never going to get to this line. We never get here. Because the second a runtime error or some other exception happens, you never run the rest of the code, right? So the very first exception gets handled. If there are multiple, like if I call do stuff twice, it's the very first exception that gets handled. So we'll never get to this call either. Something like that. The very first exception gets handled, and that's the end of the whole try catch block. If you want to redo the code inside the try, you gotta like put it in a loop somewhere. Because when something goes wrong, it thinks you don't want to do the rest. That's the end of the entire try catch. All right. So really, it's this line that's going to throw an exception. We're never going to run these two lines, okay? Because the very first time an exception happens, and we're guaranteed to throw an exception in this function, we are jumping straight to a handler somewhere. Hopefully it exists, right? So then you can give as catch blocks, you can say how you want to handle each different kind of exception. So like you say, I know how to handle a runtime error, all right? And you catch it by reference always. Get in the habit of doing that, even for like ints and stuff, right? So the second you make a catch block for a runtime error, that's shouting out to C++ saying, I know how to handle a runtime error exception. Pick me. I can do it. I know how to handle a runtime error exception. Come to me if you end up with one. Jump to my code. And so you put in the body here something that handles the exception, hopefully. But I'm just going to print stuff out for fun. But normally you'd solve a real problem right now. Caught a runtime error in main, and then like here's the e.what. You can inspect the exception that got thrown to you. And that's how you can handle that. But do stuff also might throw an int or a string, so you can give multiple catch blocks. Okay? You can say that. So catch. All right, if a string gets thrown to me, catch it by reference, always. Good practice to get in the habit of doing. So when you make a catch block for a string, it's like, I know how to handle a string exception. That's what you're shouting to C++. Oops. And so, I don't know. Again, you would give you'd solve a real problem here, but I'm just going to print stuff. Caught a string in main, and here's the string. It's called S. All right? And then, likewise, if an int gets thrown, so that's another thing that might get thrown, let's catch it. You don't have to catch this one by reference, but it's a good practice. And this is, again, shouting that you know how to handle an int if that gets thrown as an exception. Caught an int in main, and it was called I. All right? So this is us setting up handlers now. All right? Does that make sense? So now, if I recompile and rerun, boop, a string got thrown. We caught it. Another string got thrown. A runtime error got thrown. We caught it in main. And then eventually it'll get to the int, but randomness, you know. Any questions about that? So the try block is, you know, you put all the code that might throw an exception, and then the second the exception happens, it jumps to the corresponding catch block for the kind of exception that got thrown, and that's the end of the whole thing. It'll never get to these 2 lines based on the program we just wrote. If you want to run these 2 lines, you need to like loop back into them somehow. All right, so put the try block maybe in a loop, or just in the handler, put the rest of the code. If you knew, like, it would have thrown it up here, so I'll put the rest of these in the body or something like that. So that's the idea. But are there any questions about that? And then it's done with the whole thing. Like the rest of your program comes after that. It'll always go here. Da da da. And so that'll always be printed, by the way. So there's that. It's always the rest of the program. Rest of the program. All right. Let's see. What do I want to do? Yeah. So let's make sure I'm saying all the right things. So try block stops running when the first exception happens. I think I've said that enough, right? If you have a very long try block, that means you might have to add a lot of catches, right? Because there might be all of that code might throw a bunch of different kinds of exceptions. You might have to recover in weird ways. So you just got to worry about that. But that's kind of a fact of life. One thing I do want to show you is, let's see, do I want to do this now or later? Yeah, I want to show you this now. So somewhere you need to catch an exception, all right? But you can have multiple try-catch blocks along the way. Let me show that to you. And it's going to be the closest one that gets called, right? The closest one that knows how to handle something. If there are multiple try-catches, it's the closest one that C++ is going to go to. So let me wrap all of this in its own try-catch, all right? So let's do all this. And this is closer to where the exceptions are getting thrown. Does that make sense? So if I put a catch handler for like a runtime error right here, catch a runtime error, this will take priority over the catch for runtime errors in main. Does that make enough sense? Because do stuff, like that's where the error is happening. We're setting up a catch for a runtime error down here, but this is closer to where the runtime error might have gotten thrown. And so if I put a catch here for a runtime error, it's going to go to this one rather than the one in main. Does that make enough sense? That's what I'm trying to say there. So it's up to you, honestly, as the programmer. You might have more information closer to the exception, so like you know better about how to handle a runtime error over here. But like if some other code runs into a runtime error, then you're forced to go here, something like that. But yeah, that's C++'s guess, at least. It's like you must have more information, so I'm going to go to the closer one if you've set up a bunch of runtime error handlers. So this is caught a runtime error in do stuff. Cool. And so that's the idea. It's going to go to this one, all right? And let's do the same for like strings. Let's have it catch strings as well in here. And this is caught a string in do stuff. All right, so this is a little weird. Let me walk you through it. Let me show you the program, and I'll try to walk you through what's going on. If it throws an int, it's going to hit the main one still. Okay, so this is great. This is the great first example. So this one threw the int randomly. All right, so let's walk through this. So we set up a try-catch block that says I know how to handle all of these things if they get thrown, and then we call do stuff. Do stuff jumps up here. It randomly threw its int, and then this is a try-catch block, so it looks. Is there an int handler here? No, there wasn't. So it keeps on like peeling off the layers of an onion, like try-catch. Think of it like an onion, kind of. And then it comes back to this try-catch block. It was also inside of this one. So it checks these handlers. Do you know how to handle an int? And then it finds one finally. Yes, main knows how to handle an int. And so that's where the handler happens for the ints. Okay. But randomly, if we throw something else, let's see here. Caught a string in. What's going on here? Oh, nice. That's actually really funny. I don't want to do this. Now this is not applicable anymore. Excuse me. So let me have it throw a string again. That was a little confusing. Because technically it didn't throw an exception anymore. There we go. So Caught a string and do stuff. Cool. So here's what's happening. So now we're setting up a try-catch block. We're saying I know how to handle all of these exceptions if one occurs, and then we call do stuff. So do stuff also sets up a try-catch block. We are randomly throwing a string this time, apparently, and the second it occurs, it's jumping to the closest catch for that string. All right, and so that's where it's handling it. It's handling it here in do stuff. Okay. It's not jumping to the mains handler for strings because that's farther away from the exception. C++ thinks that the closer one has more knowledge, it'll do the right thing better than the main one. Okay, and so then technically this try block did not throw an exception, and so it will run the rest of the code and it's done with the whole thing and it hits the rest of the program. Okay, does that make enough sense? That was a lot. This might be something to study for sure, but that's what's going on. And again, if it throws a runtime error randomly, eventually it will, then again it's going to the closer handler, and that is because like here's where it happens, right? It's really this is where the throwing occurs. It's like where's the closest function call on the stack with a try-catch block that knows how to handle a runtime error. And there it is. But ints, though, we didn't set up a handler for ints, and so if an int gets thrown, it's got to go to the closest handler for ints, which is down in main still. Okay, that's the only place we said we knew how to handle an int. Any questions about any of that? All right. So I do want to draw a picture. That might help here. It's very similar to a stack diagram. So like, here's what was going on. Let's say that we threw a string. All right. Exceptions are great because you can catch them anywhere, far, potentially very far away from where the error happened. As long as you have a try somewhere, C++ will find and jump to the closest handler. So it's really building up a chain of handlers, a chain of catches, and it knows which one's the closest one. Right? So just like we had a stack, like main was calling do stuff, which called apparently, let's pretend it called throw string, which threw that string exception. So we were here on the stack. There's also a corresponding exception handling stack, right? And this is how I want you to think of it. I'll draw it in green. So that in blue is the normal function call stack. That's the normal stuff. But there's also, once exceptions are in play, there's also an exception handler stack. And here's how I want you to think of it. All right. So every time you set up a catch block, every time you're inside of a try-catch, C++ remembers. It's like, all right, I'm inside of this try-catch. Here's what I know how to catch. Main knows how to catch a runtime error. Main knows how to catch a string. Main knows how to catch an int. All right. So it's like building up a stack of that knowledge whenever you're in a try-catch. So it's like main knows how to handle a runtime error. Main knows how to, we also set up a catch block for strings. Main knows how to handle a string. Main also set up a catch block for ints. Main knows how to handle an int. So it's saying all those things, and it's building up this exception handler stack, right? And then it's still inside of do stuff, right? It's running do stuff, and so it's also setting up a try catch here. And this is saying do stuff knows how to handle a runtime error. Do stuff knows how to handle a string if you're inside of this block, this code here. So it's adding to the exception handler stack. It's like, all right, do stuff knows how to handle a string. Do stuff knows how to handle a runtime error. All right, and so this is why when the string gets thrown, it's going here, because here's what C++ does. Right? The second an exception happens, it looks at that handler stack from the start, from the top of it, and then it starts like chopping stuff off until it finds somebody that knows how to handle that type that got thrown. So a string just got thrown. So it's like, all right, runtime error, that's not a string. Chop. It's going to pop that off. And then it's going to find at the top now a string handler. All right? And so this is the closest matching handler that it will find, and it will go to there. And it will use that to handle the error. This is the closest matching handler. And that is the key. All right? Does that make it a little bit more sense now? Why it's going to pick the closer one? That's kind of what's being set up secretly in memory somewhere. Okay. All right. If we are happy with that, let's actually use exceptions to solve a real problem rather than just print stuff. All right. Let's go back and let's fix that division example. All right. Let's throw maybe a runtime error. And let's handle that exception by maybe asking the user for a new divisor, because that's a valid way to solve the problem. The user typed a bad divisor. We want them to give another one that works. And we'll just keep asking them as long as it's not working. So let's do that. So I guess I'll copy in the other one. This exists. Here's the old one. Disgusting. Not using exceptions. And then I want to use a runtime error. So I'll include the standard except library. And then I'll do this. So here's the goal. The throwing happens when you notice the problem. So divide still needs this if statement. But it doesn't have to like pick a weird value to return. It's just like, all right, if the divisor is 0, throw a runtime error. I notice an issue, somebody else go and deal with it. All right? You do not have to catch the same place you throw. That makes no sense. You could have just used an if statement, right? So the whole point of exceptions is to throw somewhere and maybe far, far away from the throw, catch it. Not in the same function, that's for sure. So division by 0. We don't like that. So that's getting thrown now. And it's somebody else's job to catch it. Somebody else's job, the person who called divide maybe, all right? Here's the goal. I want the user to do this. Like, I want them to give me a good divisor, and I want this to go through, all right? So, until the user gives me a good one, I'm just going to repeatedly, while true, try to do all this, because it might throw an exception now. Does that make sense? So try to do all this. The divide might throw an exception. So just make sure that's in the try block, that's for sure. And then if we get a runtime error thrown to us, because that's the one thing that might be thrown from the divide, right? Catch a runtime error by reference. Runtime error, reference E. Then we want to handle it, right? So handle the runtime error here. So handle the error by asking for a new divisor. That's a valid way to solve this problem, I would say. And so we just say like cout. Can't divide by 0. Try again. Anyway, all right? And then it'll like ask the user for something new if we allow this loop to continue. So the goal is, if divide throws an exception, we'll jump to the catch block, and then we'll keep continuing the loop again. We'll do the try catch all over again. If the divide finally works and it gives back a value and it does not throw an exception, we will get to this next line, right? And there we could maybe put a break that will get us out of this infinite loop. That's how I'll solve this problem. All right? So again, divide notices the error, it throws the runtime error, and here we are in main catching it and handling it. This is a real example, finally. Boop. So enter divisor 2, like it works in the program. But if you enter divisor 0, throws an exception, we catch it, can't divide by 0, try again. It does not hit the break, and so it runs this body all over again, which is the try catch, asking for a new divisor. And you can give 0 all day long until you give a value that works, and it will finally be happy. And then hit the break and stop the program. All right? That's a good example of actually using try catch to handle an error. Any questions about that? So it's divide that noticed the error. Somewhere later, we have to catch it. All right? Somewhere outside of that divide function. Because it was our fault. Which one? No. I want them to use the types for now. That's black magic. You can learn about later. So, yeah. There is a fancier catch, but I'll let you learn about it later. Dun, dun, dun. I think that's what I wanted to say about that. For our last topic, I'd like to have you try all this. So, let me give you all this code that I wrote just now. So let's I don't know. Give me a second. I'll put this in the code from class, because here's what I want you to do. Go to the code from class page, please. You've got my code now. And what I want you to do is find our factorial example. So like, where was recursion? Lecture 22. So either, I think I also did on lecture 21. So either lecture 21 or 22, doesn't matter. The code from class page will get you there in either way. So one of those folders has our factorial. So I want you to go to the factorial function, which it might be 22. I honestly don't know. But we'll get there one way or another. We'll find it. So here's lecture 22. And no, that was fancier stuff. So factorial is lecture 21. So if you want to go to lecture 21, there's factorial stuff. Factorial.cpp. So take this file, copy and paste it, just the normal one, the recursive factorial. And then take the stuff from today. Look at my example of like fixing divisions, throw, try, catch, all that stuff. So that's here too. That's lecture 23. We just made all this code. I just gave it to you on the code from class. That plus the factorial, I'd like you to do this. Because notice the factorial function has an issue, right? If you're running this code, factorial, let me copy it in so that I'll change it to later. So copy lecture 21 factorial.cpp into here. I'm just going to take the recursive one only. There. Do you remember how I said there's a problem if you call factive like -1 or something? Because it'll never hit the base case. It's just going to always keep subtracting. All right, factive -1 is -1 times factive -2, which is -2 times factive -3, which is -3 times factive -4. It'll just go on forever. Stack Overflow, right? So we don't like that. Wouldn't it be nice if you enforced the fact that fact of -1 could never happen? So try to add an exception case to this. I'll give you a few minutes to try it, but here, let me try and explain it as good as I can. Let me give you this code here. I'll paste it. I'm like, here's factorial. Try and fix it. Try and make it so like fact of like 0, fact of -1, definitely -1. Try and make it so that those don't work. Because like you get to this line normally and you don't want to have it continue because fact of -1. We'll try fact of -2, which we'll call fact of -3 recursively, all the way down to -infinity if that existed in int form. So try and add a case, a check for like negativity or like less than 1, because that was the base case that we chose. Anything less than 1 is going to blow up. Throw an exception instead. Don't let it stack overflow. Does that make sense? It's a valid place to put that. So add an exception case to your factorial function here and see if you can catch it in main. Try to call factor -1. Make it not error out. Make it not stack overflow. Okay? I'll give you a few minutes to think about that. Any questions about the question, though? Give that a try. You'll need an if statement. Another if statement for all that, I would say. Similar to what we did for division. Message that you want runtime error, throw a string even if you wanted to throw anytime you want. So that's fine. But you gotta catch it too. Well, it's also great because it makes it so that you don't have to return an int, like some weird valued int, like -1 or something, when things go wrong. Throw an exception. That's a separate thing. I'll give you about 2 more minutes, and then I'll show you how I might think about this. Okay. Did any questions come up as we were trying that? Did it make enough sense? Oh man, let's get a new one of these chairs, man. I just need to pop this off. So, what do we want to do? Well, let's make it so that fact of -1 never happens, or even fact of 0, honestly. Because the base case we chose to be 1. And so anything smaller than that is going to hit the recursive case forever. We'll never get down to 1. Because it's already smaller than it. Okay, so what we will do is, let's throw a runtime out. It's a pretty standard one to want to go and throw. So if n is less than 1, which means it'll never hit the base case, ever, well, let's throw a runtime error. And I could totally make a runtime error object like this, like runtime error, or e again, give a string and then throw it. But you can also just call a constructor by itself. That's totally fine. Like you were doing in your lab for rational numbers. I showed you that. Runtime error can't calculate the factorial. At least this program can't calculate the factorial of numbers less than sad face. Okay, so the addition of that now means that anybody who calls us with a bad value is never going to get a runtime error. Well, they will, but they'll get a runtime error exception if they don't catch it. They're never going to get a Stack Overflow kind of runtime error, though, right? That's the goal. And so anything that might throw an exception, let's put it in a catch block, or a try block with a catch attached. So, like, let's do this. Try both of these. So the first one's going to succeed just fine. It'll calculate 5 factorial, but the second one will fail, and it will throw a runtime error. So we can catch that by reference, of course, and handle it in some way. I'll just print out the .what method call as usual. But that is that's how it could work. So there is the use, there is the throwing. Hopefully that makes enough sense. Now where am I? CD lecture 23. Boop. And so the first one works, and then it hits this one, and it doesn't print anything. It doesn't give a number back because it just immediately throws. It stops the normal course of action for that function, which is great because you didn't want to return anything. It wouldn't have worked. So that's the beauty of exceptions. Like somebody somewhere notices something going wrong, and then far away from that, somewhere else, you can catch and handle the problem. That's the whole point. All right. It's like you're able to send messages across function boundaries, maybe multiple function boundaries, with these exception handlers. All right. So I think that's all that I wanted to say. Any questions about that? And it's a nice feature, I would say. Good to have. Good to know about. So if we are happy, I think that's all that I wanted to do today. So I'll give you a new lab next time, but that is a problem for next time.